In this video, we are going to look at dimension reduction, a linear method called Singular Value Decomposition. And in fact, we're going to get even more specific than that because we are going to do a form of Singular Value Decomposition, SVD, called Latent Semantic Analysis, LSA. This allows for dimension reduction of text. So we are going to identify the different types of documents by combining TF-IDF and KMeans clustering to group our documents that have common language. So remember, KMeans is our clustering approach, and our TF-IDF is used, we talked about when we are doing text mining. So we're going to take documents, and since it's appropriate, we're going to take documents about generative AI and see how well it does at identifying the documents. So we're going to go into our dimension reduction workbook. And so just a reminder, you will find that dimension reduction workbook at drstephpowers.github.io/BIA. And we are working in the workbook called Dimension Reduction. Now, when you click in here, you are going to need a couple files, not just the Python workbook, but we're actually going to be loading up a number of PDFs. So you're going to need to grab these PDFs here, dump them into your Google Drive. We're going to port them into our Python workbook so we can analyze the text. All right, so let's go in. All right, to do latent semantic analysis, we are analyzing text, so we are going to install Textract. This allows us to extract text from documents. So we're going to install this package. Load. I think I have a note here. Now, the note with this particular package is you need to run it twice. So hit install once, let it run and finish, and then hit it again. I don't know what's with it, but it does require the double install just to make sure it has everything. Probably the order that everything is, the order that all the packages are installed, it runs it, thinks it has it, you got to run it again to make sure it really does have everything. So we'll just go twice. So you can see when you're done, it should say requirement already satisfied, already satisfied, already satisfied. So everything is all clear once it finishes. All right, there we are, good to go. All right, so we have run it twice. Now, what we're going to do is we're going to import 5 documents, okay? So you should find all 5 of those documents. Again, if you here on the right, you will find all those documents, download them, dump them into your Google Drive. We need to specify where it's going to go to find those. So again, make sure, if I just switch back again, that you from google.collab import drive, mount your drive, and then we want to link to these particular documents. So in my drive, I have them in a folder called BIBA Handbook, and inside that they're in a folder called Chapter 7, and these are PDFs. So there should be a PDF extension for all of these. And we're going to use that package we just installed, that Textract, to process these. So we're going to import the package we installed, and then what we're going to do is we're going to call these different PDFs. So one is a document about artificial intelligence from the European Union. The next one is the document on artificial intelligence from the US government. Then we have 2 from the Canadian government. And then I have a document here that's completely unrelated to artificial intelligence. This one is a Red Deer Polytechnic policy on academic freedom. Okay, so we have documents here that it should recognize are all similar. They're all guidance on how public officials should be using AI. We have 2 versions from Canada because they're slightly different. So one is not quite the same as the other. And then one that's not AI at all. So we want to find out is whether or not we can create a model where it is able to identify whether the text is about AI or not about AI. Now, these documents, some of these documents are quite big, right? 20 pages or so. And so it is a lot of text. So we can use our dimension reduction method to help reduce all this information, right? Every word is a variable, to reduce that down for our analysis. So step one here is going to be porting all of this information in. Now, the next step, and you've done this already in other videos, is we need to clean up the text. So we're going to import the package called re, and we're going to create our own little pipeline here where we are going to tell it to substitute out a number of different symbols. So we are getting rid of punctuation, we are getting rid of returns, we are getting rid of extra spaces. So all of these are saying substitute this with emptiness in the text, okay? And if there's email addresses, it's removing those. If there's URLs, it's removing those. So all of these are trying to address all these different weird things that show up in text that really don't add value for our analysis. And then as we port, because the way we bring this in, any type of spacing, returns, that type of thing, it all is turning it into symbols here. And so we need to replace those with nothing, right? We get rid of them entirely. And that's why we have these weird symbols, comma, and then we have quotes around nothing, and we're applying it to the text. So by creating this as a function, we can say, here's the function clean test. It applies to the text. And then what we can do is then we can take our function and we can clean the Canada, the US, the EU, the second Canada, the RDP document. So let's just clean each file. Okay. And so if you want to take a look, I'll just type in AI can, we'll get a lot. But you can see now we have all this text. They've removed the URLs. You don't see any /ns, which is what you would see if someone had hit return. Return tab, double spaces, all of those turn into symbols when we port them in. All that's been removed. All right, now we're going to do TF-ID vectorization. And so from sklearn.feature_extraction.text, we're going to import TF-IDF vectorize. And then what we're going to do is we're going to create a function here that is going to apply this tokenization to our text. What it's going to do is it's going to remove the stop words that are the English stop words. That's because, as we learned from our previous videos, if you have an A or a the, those words don't add any value. So we just remove the stop words, those words that are, just part of the English language, but actually don't have meaning. And so what we're going to do is we're going to clean it up. We are going to fit and transform it. So we're going to tokenize it, and then we're going to get the feature names. So we're pulling out the key words that it's finding in the text. Okay. So we're going to create text, and text is going to be made up of our documents. So we have AI can, AI US, AI UE, AI can 2, and RDP. These are our different texts. And so we're actually just going to compile those together into our list here. What that essentially does is it says, here's the blurb from one, comma, here's the blurb from the next, comma, here's the blurb from the next, okay? Then we can apply the tokenization here to that whole list and not just have to do 1, 2, 3, 4. We can do it to everything. And what we wanted to pull out is we wanted to pull out this matrix, and we want to pull out those keywords. Okay. All right, now we're going to put it into a data frame, into a table that makes it easier to look at. So make sure you have imported pandas as PD for this to work. That's the PD part. We're going to turn into a table. The table is going to have the columns are going to be the feature names, these words. And we're going to then create this. So let's take a look here. PD is not defined. So there you go. I did not do import pandas as PD. All right, now let's give that a try. Okay, so what have we created? We have created this table here. Now, what we have here on the column, so this TF-ID underscore mat, this is our different texts. AI-CAN is first, then AI-US, then AI-EU, then AI-CAN2, then RDP. Those are our texts. This are the words. Okay, and here's the word 0. Okay, so what we have here is our TF-IDF. And so if you recall from our video when we're looking at text mining, right, we've talked about how TF-IDF is determined. So just to recall, if the TF-IDF is low, then it is going to be a word that appears in every document, and higher TF-IDF indicate that they're keywords. So the higher the value, the more it's going to be a keyword. And if it is a low value, then it is going to appear in others. And just a reminder, that the term TF-IDF is term frequency inverse document frequency. That's where it comes from. And so that's why we look at it, it's looking at how prevalent the word is throughout the documents. So we have to have multiple documents to compare. And then how often does that document, or how often does that word appear? All right, so what this is helping us flag is keywords. That's the whole point of this. Okay, so what we're going to do is let's look at, for example, table 1. So table 1 is our DF, TF, IDF, our data frame for a TF-IDF. Index location 0, so that means it's going to be this first row here. And what we're looking at is that means that it is going to be the AI document from Canada. So the AI document from Canada, we're going to oh my goodness, the words are not coming to me today. We're switching the columns and the rows. I'm gonna say transform, but that's not right. Crap, whatever that word is. Switching the columns and the rows. And then we're gonna sort the values, and we're sorting the values, ascending equals false. We wanna go descending instead, right? So what that tells us here is the keywords in the AI Canada document is generative AI use 2023 in tools, and we keep going. Okay, so looking like a document about generative AI and how it should be used. All right, what about table 2? So just a reminder, table 2 is the US artificial intelligence document. And so here we go. We are taking our data frame on TF-IDF. We're taking the index location 1, so 0, 1 is going to be the second row. We are going to turn the rows into columns and columns into rows, and then we're going to sort the value. So you can see how we're inverting this so that we're looking at just a row, but we're looking at it in column form here. Man, that T word is not coming to me. Transform, It'll come to me in the next video, which will be 0 help. All right, table 2, US. Top words, systems, data, automated use, AI. So a systems approach to how do we deal with data looks like that might be the focus of the US document. And we could keep going. We could look at table 3, which I'm guessing is the EU. Yep, 3 is the EU. So same thing. Switch rows and columns, sort the values. This one's about EU, Europe, data systems, artificial intelligence. If we look at table, we'll call table 4, index location, this one is 3 here. This is the second Canada document. Notice if we look at some of the words that rate the highest here, they're on decision, directive, automated, Canada. These words are a bit different here, still automation, but a bit different words here, suggesting perhaps this might be a different type of document. And then if we look at the Reger Polytechnic document, you'll notice that this doesn't discuss automation at all. Freedom, academic, faculty, Reger Polytechnic, Red Deer. So when we run our algorithm, we expect that it's going to at least identify that table 5 is not like the others. All right, so how do we do this? Okay, so we have our text. We have looked at kind of some basics of the tokenized words here and their TF-IDF values. Now we want to do is do our principal component analysis. So we are going to use SVD. It is called truncated SVD. It comes from sklearn.decomposition. And then we're going to use our K-means clustering. So unlike our previous example, we did dimension reduction. We applied it to classification models. Here, let's apply this to cluster analysis. So our dimension reduction methods we can use for classification or clustering. So we're going to create a model called truncated SVD. We'll call it SVD lowercase. And we'll make the number of components here 2. And that's because ultimately we want 2 clusters. About AI, not about AI. So we're going to make the number of components here equal to the number of clusters we're looking for. So first what we're going to do is we're going to do our dimension reduction. Call the truncated SVD, specify the number of components is 2, and then fit and transform. All right, and we're fitting and transforming on this table here, this DF, TF, IDF. So if you are using this method to categorize documents, you need to have created this table where your documents are the rows, your keywords are the columns, and your TF-IDF values are what is in the database. So by creating this from your data sets, then you can do this cluster analysis here. All right, so that's run quite quick here. Now we can do our K-means, number of clusters equals 2. We call the model, we fit the model, and here we're just doing fit and predict all at once. So kmeans.fit_predict. Basically what we're doing here is just combining the fit code and the predict code into one quick step. So you can use this with what we were doing before, or we could separate it out. You could do kmeans.fit and then kmeans_text.predict, and you can have those extra rows. Our coding can be more precise like you see here. So you choose. All right, now we have done that. We have fit and we have predicted. So that means that it has values, that it has predicted, it has given labels to these groups. So what we want is we want this K-mean text. We want those predicted labels. And we want it so it's easy to understand. So we're just going to create ourselves a table where we take the titles. This is the same order as before. So ACAN, AIUS, AIEU, AICAN2, RDP. Okay? Those are our 5 different documents. That's the same order we loaded them into that data frame before. So then we're going to create a new data frame using pandas, pd.dataframe. And we are going to call one column labels. So we're using dictionary style here. Here's the variable, here's the values, here's the variable, here's the values. So here's the label. And then we're going to pull this K-mean text. These are the predicted labels. K-mean text. And then for docs, we're going to pull the titles, and those titles are from this list we just gave it here. Okay. And then we're going to have it, we could have it sort values. If you sort by label, it'll then put them together, right? So it's not just 1, 0, 1, 0, 1. We can then group everybody together. So let's run this. Okay, here's what it says. it says AI CAN, AI US, AI EU, and the second AI CAN document are all one group. And then the RDP group is a second group, which is what we expected to see, right? That makes sense because these were all related to artificial intelligence, and this one was related to academic freedom. Now, we knew what we were looking for just so we can see how well this works, but you could then do this for lots of documents. You could then automate the process of having it scan and analyze a bunch of things. This is the process you would use if you're trying to, for example, shortlist a bunch of resumes. You could dump in a bunch of resumes and have it cluster them together. And if some of those resumes are ones that are particularly good, maybe you put them in there as examples of the type of qualifications you're looking for. Then what you're looking for is the other resumes that it clustered with those the examples that you quite liked or the ideal ones. So here we got two groups. We have the AI and the non-AI. So we could take this code that we just created, right? This was a lot here. We can actually create a pipeline to really simplify the code. So we could take our table and we could create a pipeline that would do a lot of these pieces. So only a couple lines of code would take care of all of these components. So for example, all the code we just ran, if we had already created, so we go back in time, once we create our table here, this DF, TF, IDF, so you get yourself to this table here, then we can create a pipeline that will then do our dimension reduction and our model, and we'll then pull together our values. So if we want to create a pipeline here, machine learning has built-in pipelines for when you are calling sklearn packages, so cluster or classification models from sklearn, then you can use this pipeline. So from sklearn.pipeline, we're going to import make pipeline. And so then all we need to do is say, okay, we're going to use the SVD, our truncated SVD with two components, our KMeans with two clusters. We give those two names, and then we do make pipeline. We say first do our dimension reduction, then do our KMeans cluster analysis. Then we say pipeline.fit, and then we say pipeline.predict, and it will output our labels. So we can simplify it like this as well, and you can actually combine the fit and predict together like we did here as well. Okay, so if we run this, what we get is when we call our labels, we get the same kind of classification. Here it's just calling them different, like it's just two, but it's saying, okay, all the AI ones will label as group 1 and the RDP will label as group 0. So it's telling you the same information. What if we do 3 components and 3 clusters? Because remember, there's that second Canadian document that is not really about generative AI. It's more about, I think it's more about automation. So it's not the generative AI ChatGPT documents that the other 3 are. So let's see that if we do 3 clusters, 3 components, we make them match, can it identify that that one also doesn't match? Okay, now it's close because it is similar in terms, that's why the 2 categories that put it together. But if we give it an opportunity to do 3 categories, it should be the one that gets rejected to be the 3rd category. So 3 components in our truncated SVD, 3 clusters in our KMeans, we've named them both. We make our pipeline, so it does our dimension reduction first, then our cluster analysis. It fits it, it predicts it, it outputs what the labels are, And so what you'll see, AI Can, AI US, AI EU, those 3 generative AI documents that is clustered together. The one that's about automation for Canada is here as its own group, and the one about academic freedom is a 3rd group. So you can see how it's able to cluster the text based on themes.